Before we continue our discussion on the material of Chapter 1, we're going to take a quick break here and talk about units. Units are absolutely important, critical in the world of physics, in the world in general, I'm going to say, because units give definition. I'll give you a quick example. I have 5. Okay, now to most of you, when I said that you hopefully thought, that makes no sense. I have 5. I have 5 what? I have 5 books. I have 5 awards. I have 5 minutes left to work. I have 5 items on my shopping list. I don't know. Okay, so you need something to define what the number represents, and that's what a unit is. The unit describes what the number is. It gives the number meaning, really. Here in the United States, we often use the English system of units. That means that distance is usually measured in feet, the temperature is measured in Fahrenheit, and forces, including weight, are measured in pounds. There are others. This is enough for now. We have some issues with the English system. For example, there are 12 inches in a foot. There are 3 feet in a yard. There are 5,680 feet in a mile. I hope I've got that number right. 16 ounces in a cup. You see that it's these numbers keep changing. There's no clear connection between all of these units. As such, it's easy to forget how many of one unit are in another unit, how many feet are in a mile, as I just showed you. English system works. It does work, but it's not the most convenient system. The world outside of the United States, for the most part, uses the metric system, which tries to simplify this a lot. And it does this by creating connections between different units by powers of 10. By powers of 10, I mean 10, 100, 1,000, 1 million, 1 billion, 1 trillion, and so on. And using those, we can convert from one unit to another. All right, the basic units in the metric system, for example, we have the meter, which measures distance, temperature is measured in Celsius, and force, including weight, is measured in the Newton. Now, many of you say, wait, I convert my weight from pounds to kilograms. Okay, there is a slight difference. The kilogram technically measures mass. We'll talk about that in another video. But we do have a relationship between the pound and the kilogram, but that only works at the surface of the Earth. If you go higher in altitude or hypothetically to another planet, then that relationship doesn't work anymore. We'll talk about that in another video. But technically, the metric unit for force, including weight, is the Newton. All right, now I'll show you more about the metric system in just a minute. Let's first talk about how do you go back and forth between the metric system and the English system? Or between any one unit and another? How do you go from inches to feet? Or how do you go from ounces to pounds? All right, we're going to talk about that. To convert from one unit to another, there are 2 basic steps. The first, you need to find an equality. How many inches are in a foot? How many feet are in a mile? So on. You find an equality. Then using that equality, we take our number, we multiply it by the part of that equality with the unit we want, divided by the other part of the equality, the unit we currently have and want to get rid of. Let me show this to you in an example. Let's say we want to convert 364 meters into feet. We're good old-fashioned Americans. We don't understand meters, so let's go from meters to feet, which we understand a little bit better. Now, for those of you who understand meters better than feet, you can flip this around too. It goes the other way as well. First thing we need to do is find an equality. How do we relate meters to feet? Well, it turns out that 1 meter is the same distance as 3.25 feet. It's a little rounded, but it's close enough for what we need. 1 meter is 3.25 feet. Now that we have our equality, let's convert the unit. We're going to take our number, 364 meters, multiply it by the part of the equality with the unit we want, 3.25 feet, divide by the current unit, part of the equality with our current unit, 1 meter. Okay? So 364 meters times, let me just emphasize this here by saying, there's our 325 feet, and here is our 1 meter. Again, the unit you want is on top, and the unit you want to get rid of is on bottom. All right? Then what happens? Well, turns out that if you take a meter and divide by a meter, those meters cancel out. They're gone. Then you just do the math. 364 times 3.25 feet divided by 1. Do that math and you get a total of 1,183 feet. So 364 meters is just over, a little bit over 1,000 feet. Okay, now as we go through the course, we are going to use a lot of units in the metric system. That's what we're going to focus on in this course, because that's what's primarily used in the scientific community. So in order to help you understand the metric system, we need to show you how it works. Metric system uses names to denote powers of 10. For example, 1,000, we give it a name of kilo. And kilo we abbreviate with the lowercase k. So kilo means 1,000. So anytime I have a number with the word thousand in it, I can replace that 1,000 with kilo. So I have 5,000 meters, replace 1,000, I have 5 kilometers, or 5 kilometers is a more common way of pronouncing it here in America, at least. 5 kilometers then would be 5,000 meters. Okay. Now, in this table you have on the slide, we have a number of the most commonly used units. Hecto is the name for 100. Kilo is the name for 1,000. Mega means a million. Giga means a billion. Tera means 1 trillion. Okay, these are all units that are larger than our base unit. By base unit, I mean meter or liter or gram or degrees or whatever. Okay, these, you can see here below the names that I give you, I show you the basic equality. 100 meters is 1 hectometer. 1,000 meters is 1 kilometer. 1 million meters is 1 megameter, and so on. Again, all we're doing is taking the number 1 million and replacing it with the name mega, and doing that for all these others. Now on the right side of the table, things kind of change just a little bit. These are prefixes that indicate that the number is smaller than the unit. So in this case, we're talking about numbers that are smaller than 1 meter. The decimeter is 1/10 of a meter. So that means 10 decimeters is going to give you 1 meter. Centi means 1/100th. And we can remember this because we have 100 cents in $1. Okay, that's where the word cent came from. Cent means 1/100th. So 100 centimeters in 1 meter, 100 centigrams in 1 gram, so on. Milli means 1,000th, so 1,000 millimeters in 1 meter. Then we get into a couple that are a little less familiar. You've probably heard them, but mathematically you probably haven't seen them as much. Micro, you have this interesting little character right here. This is the Greek letter M. It's called mu, all right? You don't have to remember that. Just remember that this symbol means micro, and that means 1 in a million, 1 out of a million, which means 1 million micrometers is equal to 1 meter. Nano is another one that you've probably heard. That means 1 billionth. So 1 billion nanometers is in 1 meter. Now in this table, I used meters. You could very easily replace all of these units that I have in the table with grams. 1,000 grams is 1 kilogram, or 1 million micrograms is 1 gram, so on. So here are the base units we generally use this for. We have distance, which is the meter. Volume is generally measured in liters. Mass is measured in grams. Pressure, not as commonly seen, but we're going to see it a lot in this course. The Pascal. So, and I have here a relationship showing that 100 pascals is 1 hectopascal. This unit in particular, we are going to use all over the place in our course. In fact, this unit, 1 hectopascal, we also call it a millibar. That's another name for it. We're going to use this all over the place throughout the course. Forces are another common base unit. Time is a base unit. We often give time in milliseconds or microseconds or sometimes even nanoseconds. So we can use these metric prefixes with